Hello dear students, I hope you are all doing well. In the last video, we talked about acids. Now let us move forward and learn about the chemistry of bases. According to Arrhenius concept, bases are substances that release hydroxide ions in water. Depending on the number of hydroxide ions released, we classify them into three types: monoacidic bases, diacidic bases, and triacidic bases. Monoacidic bases, these release one OH negative ion per molecule. For example, sodium hydroxide and potassium hydroxide. Diacidic bases, these release two hydroxide ions per molecule. For example, barium hydroxide and calcium hydroxide. Triacidic bases, these release 3 OH negative ions per molecule. An example is aluminium hydroxide. However, Arrhenius definition does not always apply. A broader definition of bases is that they are substances that react with acids to form salt and water. Only keep in mind that not all bases are hydroxides or oxides, and not all bases dissolve in water. HCl, that is hydrochloric acid, reacts with zinc oxide to form water and zinc chloride. Since zinc chloride is a salt, we can say ZnO, that is zinc oxide, is a base here. But when lead oxide reacts with hydrochloric acid, it forms lead chloride, water, and chlorine gas. Because of this additional byproduct, that is chlorine gas, lead oxide is not considered a base in this reaction. Based on solubility, we classify bases into two types: water-soluble and water-insoluble bases. Water-soluble bases, they are also named as alkalis. These include sodium hydroxide, potassium hydroxide, sodium oxide, ammonium hydroxide, calcium hydroxide, and many more. Note: calcium hydroxide and ammonium hydroxide are partially soluble in water. Now, water-soluble bases. These include zinc oxide, magnesium oxide, ferrous hydroxide, ferric hydroxide, and many more. Remember, all alkalis are bases, but not all bases are alkalis, because some bases do not dissolve in water. Dear students, we also classify bases into two types based on their strength: strong bases and weak bases. Strong bases include substances like sodium hydroxide and potassium hydroxide. In these bases, there is complete ionization, meaning the reaction does not reverse. Weak bases only ionize partially in water. For example, in ammonium hydroxide, there is an equilibrium between ammonium and hydroxide ions, so the ions can recombine. Now let us see how we can prepare bases. Water-soluble bases like sodium hydroxide and potassium hydroxide and calcium hydroxide can be made by reacting metals like sodium, potassium, and calcium with water. This produces the respective bases like sodium hydroxide, potassium hydroxide, and calcium hydroxide, along with the release of hydrogen gas. Insoluble bases can be made by reacting a soluble salt with an alkali like sodium hydroxide. For example, when zinc nitrate, a salt, reacts with sodium hydroxide, it forms an insoluble base called the zinc hydroxide and sodium nitrate as a byproduct. Now, let us talk about the chemical properties of bases. Bases like sodium hydroxide react with active metals such as zinc to form a salt called the sodium zincate and release hydrogen gas. Bases also react with non-metal oxides like carbon dioxide, sulfur trioxide, diphosphorus trioxide to form salt and water. For example, calcium hydroxide, also known as lime water, reacts with carbon dioxide to form calcium carbonate and water.